Hi guys, welcome to your Tuesday maths lesson. So, last 3 weeks of our home learning lessons. This is how it's going to run. We're going to have our arithmetics on a Monday, we're going to have our problem solving questions on a Friday, and then 3 lessons each week for the next 3 weeks. We'll focus on our fractions, decimals, and percentages learning from earlier in the year. We've done lots on fractions, decimals, and percentages, so it will be exactly what it says there in the Walt, a recap. Let's get into these questions then. Random selection of different questions I'll go through today. I'll do a little bit of I do and you do. So if you've got a pen there to hand or a piece of paper as well, that'd be handy for you to be able to answer the questions when it gets to your turn in a moment. So fractions of shapes. Here we've got 5 different rectangles, all broken up into 10 equal sections. The first thing I would do if I ever get something like this where you've got to match a shape to a fraction is I would write down the fraction that I've got shown in each shape. So here I've got 8/10. Underneath that I've got 3/10. 3 of them are shaded. The third one has been done for you. You can see that 7 of them have been shaded. It's been labelled for you already. This one's got 6/10 shaded in. And the final one has got 5/10 shaded in. By doing this, it then allows me to use my equivalent fraction knowledge to be able to match up the answers accurately. So I'm looking and I'm thinking, well, what's fraction straight away? Does it stand out to you that you can match up really easily? 5/10 we know is equivalent to 1/2. Hopefully we spotted that one nice and easily. Any other ones that we can spot quite quickly? Well, I know if I divide my numerator and my denominator of this fraction by 2, it will give me 3/5. And I've got a 3/5 there, so I can label it like so. The actual simplest one here, which I probably should have labelled first, is the 3/10, because I've got a 3/10 here. So to match up fractions of shapes with actual fractions, write the fractions out, and then see if you can use your equivalent fraction knowledge to help you. Have a go, if you can, at this question here. You might want to pause it, give yourself a few seconds, and I will go through the answers. So what have we got then? So we've got 1 hole shaded in here. So I can label that one hole. Here I've got 3 of my parts shaded in, and I've got 4, 8, 12 parts in total. Here I've got 10 of my 20 parts shaded in, which go like so. Here I've got 3 of my 9 parts shaded in. Here I've got 5 of my 10 parts shaded in. And finally I've got 12 of my 16 parts shaded. So once you've done that, as I said previously, you can have a go now at using your understanding of equivalent fractions to help you match up the original fractions with the correct picture. So 1 hole, quite easily and straightforwardly, matches to 1 hole. We're okay with that. Now, let's have a look. Can I say anything that's equivalent to a third? Well, if I divide my 3 by 3, it would give me 1. And if I divide my 9 by 3, it will give me 3. So 3/9 is equivalent to 1/3. I can match those two up. I've got a couple of quite straightforward ones actually here. 10/20 is the same as a half, because the numerator is half the denominator, as is 5/10. So that one can be labelled like so. It then leaves me with this one to answer here. So I've got 3/12 shaded in, and I've got 3/4 and 1/4 remaining. Well, which one would I match? If I divide 3 by 3, it would give me 1. If I divide 3 by 12, it will give me 4. So 1/4 is the same as 1/4. So I'll match those two together. And then the same here. If I divide my 12 by 4, it will give me 3, and if I divide my 16 by 4, it will give me 4. So this one's equivalent to 3/4. Hopefully you got that. Your first question today will be something similar to what we've just done there. So you might want to pause the video and answer the first question. If you want to watch the whole video, let's move on to the next question. I do, you do then for comparing fractions. So nice and straightforward, I've got 1/2 and 3/4. We've said previously we can't compare fractions with different denominators easily because it's difficult. Because it's difficult. Yes, it's difficult. So you've got to get them both to have a common denominator. Well, I know that 1/2 is the same as 2/4. So if I've got 2/4 and 3/4, I can see that 3/4 is the greater value. So 2/4 or 1/2 is less than 3/4. Same again here. I can use 16 as my common denominator. Eight times 2 is 16, so 3 times 2 is 6. 16 remains the same, so 9 remains the same. So I can put my less than symbol in again. So 3/8 is less than 9/16. So 6 steps to success here. Make sure you've got a common denominator, or find the common denominator, then find your equivalent fractions. We found that 1/2 is equivalent to 2/4 and 3/8 is equivalent to 6/16, which means you have two answers with the same denominator, which means you can compare them nice and easily using our understanding of fractions from year 4. Have a go at these two then. 1/3 and 3/6. So 6 is my common denominator. How do I get from 3 to 6? I times by 2. What do I do with my 1? Times it by 2. 1 times 2 is 2. 6 remains the same, so 3 remains the same. So I am going to be using, again, my less than symbol. 1/3 is less than 3/6. Finally, for comparing fractions anyway, 2/6 and 5/12. 12 is my common denominator. Can be my common denominator. 6 times 2 gets 12, so 2 times 2 is 4. 12 times 1 is 12. 1 times 5 is 5. And once again, coincidentally, I'm using the less than symbol. Because I can see that 4/12 is less than 5/12, or 2/6 are less than 5/12. So you'll get a question like that today, comparing fractions. Again, using your equivalent fraction knowledge to help you do this nice and easily. I think that's question number 2. Next one, ordering fractions. So again, we're going to be relying on our understanding of equivalent fractions to help us do this. Let's put them in order. First thing I need to do, I'm looking for an equivalent. I'm looking for my equivalent fractions by looking for a common denominator. I can see that 3, 4, and 2 are all factors of 12. I can times something by these 3 numbers to get each time to get 12. So that means I can use 12 as my common denominator for my equivalent fractions. What do I times 12 by to get 12? I times it by 1, so I do the same with my 5. I still have 5. 3 times 4 gives me 12. 1 times 4 is 4. 4 times 3 will give me 12. 1 times 3 is 3. And 2 times 6 is 12. So 1 times 6 will give me 6. If I was then to put them in my original fractions in order, starting with the smallest, I think we'll start with, I can see that using my equivalent fraction knowledge, because all these are the same denominator, so it all makes it nice and straightforward, I can see that out of the fractions I have here, 3/12 is the smallest, so I can tick that one off, write my original fraction, which is 1/4. I can see that 1/3 is the next fraction in my order, I can see that 5/12, which was my original fraction anyway, is next, leaving me with 1/2 as my largest fraction, smallest to largest. I'd like you to have a go now at trying to order the fractions on the screen. Again, we'll do it from smallest to largest, finding your common denominator first. Let's see how you get on. Again, this time it's going to be my common denominator of 12 because I can times 3, I can times 4, and I can times 6 by something to get to 12. They are factors of 12. So make 12 my common denominator. Start with my one that won't change because I'm timesing them both by 1. Put it in there. 6 times 2 is 12. 5 times 2 is 10. 3 times 4 is 12. 4 times 2 is 8. 4 times 3 is 12. 3 times 3 is 9. Back to my original fraction, starting with the smallest. I'm going to go with 2/3. I'm going to then have 9/12 or 3/4 as my original fraction. I'm going to have 10/12 or 5/6. And I'm then going to finally have 11/12 as my largest fraction in this range. There we go. So again, you'll have a question today requiring you to order fractions. Find the common denominator is always the best method. Finding that common denominator first will allow you to answer the question nice and successfully. If you are using equivalent fractions to help you though, make sure when you come to order them at the end, you use your original fractions. Because that's what the question asks you to do. You've used this as a method to help you, but the actual answer will be the original fractions in the correct order. Next thing, fractions on a number line. So I've got a number line here ranging from 0, oops, oh my goodness, ranging from 0 to 1. Get rid of that line that I've just drawn. Very helpful. I've got 10 jumps, 10 equal jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 jumps, 10 equal jumps. The difference between 0 and 1 is 1. So I need to do 1 divided by 10 to give me my interval, my jump each time. 1 divided by 10 would be 0.1, which is the same as 1/10. So let's just check our interval. I'm jumping 1/10 each time. Let's see if it works. So 0, 1/10, 2/10, 3/10, 4/10, 5/10, which is the same as half, and we are halfway. 6/10, 7/10, 8/10, 9/10, 10/10, which is the same as 1/2. So yes, we know we've worked out our interval correctly. Now I'm going to look at my fractions up here. If I know that I'm jumping in tenths every time, it'd be good to have all my fractions written over 10. So my 3/5 written over 10, because I'm timesing my denominator by 2, I times my numerator by 2, which will give me 6. If I want to put my 60 over 100 as a fraction over 10, I've got to divide my numerator by 10 because I divided my denominator by 10 to get from here to here. 60 divided by 10 would be 6. And a half, well, I times it both by 5 because I times my 2 by 5 to get to 10. 1 times 5 is 5. So I've got, I'm just going to move these up out of the way. 6/10, 6/10, 5/10, as well as my 2 nice easy ones here. So using my straight line, I'm going to think, where's my 4/10 going to be? Well, 0, 1/10, 2/10, 3/10, 4/10 will be there. My 2/10, that's 1/10. This must be 2/10. My 3/5, which is the same as 6/10, will be here, as will my 60 over 100. And my half remains halfway, like so. Quick recap. So you work out your interval. You then try and get all of your fractions over the same denominator, and then you can draw your lines nice and easily. I've had my go, it's now over to you. See if you can solve this question by putting the fractions in the right place on the number line. So what do? So we know that I actually got the same number line here, so I know because I've got 10 equal jumps that each jump is again of 1/10. So this fraction's fine, this fraction's fine. 2/5 is the same as 4/10 because I've times them both by 2. 80 over 100 is the same as, well, it's up to you. You could half it and half and go again. Or you might think, well, actually, I can divide that one by 10, which would give me 8 over 10 to give me a fraction like so. And then 1/2 we said before was 5/10. So I'll pop those above, get my straight line. 9/10 goes there, 1/10 goes here. 2/5, which is the same as 4/10, would go there. 8/10 goes here, and 5/10 goes there. Did you get it? Excellent. Well done if you did. The next question on your question sheet today will be something like that. Where are we up to? Nearly there. I know I've kept you for a long time. Here we're going to have a look at less than, equal to, and more than. So again, I'm using my equivalent fraction knowledge. So 2/8, can I simplify? So first thing to do, try and simplify any of your fractions. 2/8 we know is the same as 1/4. I've divided them both by 2. 9/12 is the same as 3/4 because I can divide both my denominator and numerator by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. What can I divide these two both by? I can divide them both by 4. 1 divided by 4 is 1. Sorry, 4 divided by 1 is 1. 16 divided by 4 is 4. So, which of my fractions are less than a quarter? Well, I know that 1/8 is less than a quarter. If I had a hole cut, if I had 2 holes, one cut into quarters, one cut into eighths, the 8 would be much smaller than the quarters. That would go in there, take that one off. Equal to a quarter, well, I can see that this one and this one is equal to a quarter. So I'll put my 2/8, my 4/16 in there. And 3/4 is obviously greater than 1/4. So my 3/4 will go in there, or should really have put /9/12. That's my original fraction. Have a go at that one then. How did you get on? Let's have a look. Well, less than a half. 16ths. Well, how many 16ths make a half? 8 16ths make a half. So 1/16, so 2/16 must be less than a half. 9/12. How many 12s make a half? 6 12s makes a half. So 9/12 must go in here. 16/30, well, 15/30 is a half. So 16/30 must be greater than. Sorry about that. And then finally, 24 over 50, well, 25 over 50 is a half. So 24 over 50 should be in this section here. Next one, we are going to have a look at converting mixed number fractions to improper fractions. Nice and quick this, if you remember from our lesson a few weeks ago that we spent a whole lesson on. We look at the whole number, the denominator, and the numerator. You do 3 times 2, which is 6, add the 1, which would give me 7. My denominator remains as it was here. So that would be my mixed number as an improper. Improper where the numerator is larger than the denominator. Second example, 2 times 8 is 16. Add on my 2, which will give me 18. My denominator this time is 8, but it remains 8. So 18 eighths would be my improper fraction. 2 and 2 eighths would be the same fraction but as a mixed number. Have a go at these. 5 times 5, 25. Add on my 2, 27 fifths. 9 times 4 is 36. 36 add on 7 would give me 43. 43 ninths would be my improper fraction when I am converting from this mixed number fraction. We're nearly there. We are nearly there. 1/2 add 2 eighths. Look, again, we're using our equivalent fraction knowledge. 1/2 is the same as how many eighths? Well, if I get from, how do I get from 2 to 8 times by 4? 1 times 4 is 4. So 4 eighths. Add my 2 eighths, because that remains the same, because I times them both by 1. Would give me an end answer of 6 eighths. You could half of both of those and put 3/4. That would be your simplified, or your answer in its simplest form. 2/3 take away 1/12. This is a subtract, so keep an eye out because I'm going to do some subtraction and some adding questions today. How do I get from 3 to 12? I'm going to squeeze it in here because we're running out of space. I times it by 4. 4 times 2 is 8. 8/12 take away 1/12 would give me 7/12. Can't simplify it any further. That is my final answer. Finally, fractions times whole numbers. In this case, so it's kind of like repeated addition, isn't it? 5, 6, add 5, 6, add 5, 6. Or, which will give you 15 sixths. Or you can put your whole number over a denominator of 1, which will give you the same answer when I times both the numerator and then the denominators together. Again, 2 fifths. Add 2 fifths, add 2 fifths, add 2 fifths 6 times, you could do it. Or you could put it over a denominator of 1. 6 times 2 is 12. 1 times 5 is 5. There's my answers. Have a go at these ones. So 1 times 5 is 5. 1 times 3 is 3. That is a 3, by the way. It's just a really badly drawn 3. 2 times 5 would give me 10. 1 times 7 would give me 7. Get them both right? Hope so. 5/3 and 10/7. Well, there we are. Absolute mammoth revision. So much to cover, so quickly covered as well. However, I know that we've spent a lot of time doing this. So today's lesson will be jam-packed full. 10 questions, all linking to what I've just recapped there on fractions mostly. We'll go on to decimals and percentages tomorrow, for the rest of the week, and for the next couple of weeks. Have a go. Let us know how you get on. If you're unsure with anything in particular, go back on the school website or back on our YouTube channel, and you will see whole lessons dedicated to all of those questions I have just covered. So I went through it really quickly. So if any of those are still quite tricky for you, go back and find the, I don't know, converting from mixed number to improper lessons, which they were quite early on, those lessons. So go back and see how I did it, because I've done lots more examples, showing you using lots of different visuals. For those who are okay though, this is what your sheet's going to look like today, or the first sheet of the 10 questions you've got today. Have a go. Let us know how you get on, and I'll see you tomorrow for some more recapping of fractions, decimals, and percentages. Have a great day.